Hello everyone, welcome to my presentation. Today I'm honored to have this opportunity to share with you about Apache Cassandra Java driver best practices. So, what is Apache Cassandra? Apache Cassandra is a NoSQL distributed database featuring high availability and scalability. Cassandra has a decentralized architecture. Every Cassandra instance running on the server is called a node, and a cluster of nodes can communicate to each other. Each node will hold a part of the data, and each node will be able to handle database queries from the user. So the whole cluster will appear to the user as a unified whole. Then let's say you have a Java application, and you want to send database queries to Cassandra. Then you will need to add a dependency in your Java application and use the API in this dependency package to send queries to the database, right? So this package is just called driver. And Java driver is the most commonly used Cassandra driver. So today I would love to share with you the best practices of Apache Cassandra Java driver. The first half of this presentation will be about configuration, and the second half will be about programming practices. Configuration will cover cluster connection, idempotency, retry, speculative execution, timeout, logs, metrics, and performance tuning. Programming practices, we will cover session management, prepare statement, batch data retrieval, and paging and exception handling. So let's talk about configuration first. You can configure most of the settings in the file called application.conf or application.yaml in the folder resources. And here's an example on how you can configure contact points and local data center and reconnect on init. So in terms of cluster connection, I will recommend you to specify more than one contact point for driver's initial connection. Although the driver will discover all the nodes in this cluster after the initial connection. But if you only specify one node and on application startup time, if this node is down for some reason, then the driver just has no way to discover the whole cluster. So I would recommend you put more to increase the resilience of the application on startup time. Second, I would recommend you to specify the local data center. The local data center is the data center where you deploy your Cassandra servers. That is the closest to your to where you deploy your Java applications. So given if you inform the driver about the local data center, then the driver will prioritize the local data center when sending queries, and this will save your latency. I will also recommend you to set this reconnect on init to true. It's by default false. That means by default on application startup, if the driver fails to connect to the Cassandra database, then the driver will just throw the error. But if you set reconnect on init to true, then on startup time, even if the driver failed the first time, the driver will still try to reconnect. This can also increase the resilience of your application on startup time. Now let's talk about idempotency, retry, and speculative execution. What is idempotency? We say a query is idempotent if executing this query more than once will leave the database in the same state as executing the query once. So all the read statements, like those select statements, they're all idempotent because reading doesn't even change the state of the database. But even if there are write queries like insert, let's say if it's insert to account table, columns, username and password, and the values is my username and my password. This statement is also idempotent because like executing it more than once or executing it once, it will both leave the database to the state that the record will be my username, my password, right? So such statement is also idempotent. But if your statement is to increment a counter, then it is not idempotent. Idempotence, like the driver will only do retry or speculative execution if the statement is marked as idempotent. So I would recommend you during data modeling phase, try to design it in a way that as many as your database queries can be idempotent. Also, the driver does not parse the database queries, so the driver it doesn't have a way to know whether your statement is idempotent or not. The driver will depend on you to inform whether they are idempotent. There are two ways to inform the driver about idempotence. First, if all your statements are idempotent, then you can just set in this global setting of default idempotence. This is by default false, right? But if you know they're all idempotent, then you can just set it to true. Or you can use the statement.setIdempotent API to specify idempotent or not for each individual statements. And the driver will refer to the statement idempotence to determine retry or speculative execution. What is a retry? So if the driver sends out the request and receive a response from the server saying there is an error, then the driver can maybe send the request again to the same node or to the second node, or just throw this error to the user, right? So the component that make this decision is called retry policy. The driver by default will use this default retry policy. This is good enough for most applications. So I would say best practice, you can simply leave the retry policy as it is when using the driver. And here's a chart on the behavior of the default retry policy. For example, if the server give a response of read timeout, that means we know this is a read query. This is for sure idempotent. Then the driver will just retry. But if it's a write timeout, then we don't know whether it's idempotent or not. Only if the user tells the driver that this statement is idempotent, then the driver will also retry. If it's an unavailable error, then this statement is for sure not executed yet. So the driver will retry on the next node because this node is not available. Or if it's request aborted or error response, that means we don't know whether the statement is executed or not. So the driver will only retry if the user has marked this statement as idempotent. Now, the other thing, speculative execution. So what is speculative execution? If a driver sends out an idempotent request and after some time the driver still does not receive the response yet, the driver can actually just preemptively send the second request to the second node. And if the second node replies first, then we save some latency and we will also send a request to cancel the previous query to the first node. This can significantly decrease your P99 and P999 latency. So how to turn it on? By default, this functionality is disabled. So I will recommend you to turn on speculative execution policy. This policy only kicks in if your statement is marked as idempotent. The policy that is shipped in the driver is called that you can use it, you can specify without implementing your own. This is called constant speculative execution policy. It has two parameters, max executions and delay. In this case, I put max executions of 3 and delay of 100 milliseconds. That means after the driver sends out an idempotent request, if after 100 milliseconds, the driver still does not receive anything yet, then the driver will send the second request to the second node. And after another 100 milliseconds, if the driver still does not receive anything, then the driver will send out the third request to the third node. But that's it, the driver will not send any more because the max execution is 3. That's how it works. But these two parameters, we cannot give you a recommended value. You sort of need to just test it out in your own environment. Also, you will need to balance the load and the latency, because speculative execution is basically sending additional requests to the server, right? So there is a sacrifice of the load, the throughput, the load. But in multiple cases, it's worth it to sacrifice a little bit additional load to decrease the P99 and P999 latency. So you have to you're recommended to just test it out and balance it. Next topic is about timeout. So driver has a default timeout of 2 seconds for all the queries. You can also set the timeout of individual statements to using this set timeout API. The driver during these 2 seconds, the driver will send out the request and wait for it to reply and maybe do some retry, maybe do speculative execution, maybe even reconnect. But if after these 2 seconds, the driver still does not have any result yet, then the driver will just throw driver timeout exception to the user. That's why driver timeout exception is not handled by retry policy. Some customers will ask us why it is not handled by retry policy. This is why, because retry should be done within 2 seconds. If after 2 seconds still nothing happened, then we do not let retry policy handle it anymore. We just throw to user. This 2 seconds threshold for this 2 seconds timeout is good for almost all the applications, but if you there's an exception. DDL statement usually takes more time. DDL statement is something like create table, create type. Those usually take more time. So I would recommend you to set a higher timeout for such individual statements. Logs. So I recommend you to start off from info level logging for the whole driver from at your production environment, unless you notice something wrong and you want to investigate it. And you can turn on the relevant loggers depending on what you want to investigate. For example, if you want to investigate topological changes, that is something like node disconnection or a node goes down. Such things are topological changes, then you're recommended to turn on those loggers here. Pool manager, channel pool, node state manager, metadata manager, and reconnection. You can turn the debug level logging for them. Or if you want to investigate specific queries, let's say if you find out one query out of 1 million fails for some reason, then this is query level logging. You're recommended to use request logger. Request logger is a class that is built in the driver, and you only need to turn it on in the configuration. And here are some settings, something like whether you want to log success queries, this query that succeeded, or what's the max query length that you want to put in your log. You can change those settings based on your need. Metrics. Metrics are very important to give you insights on how your application is doing. Here is a code snippet on how you can register a metrics registry. The default metric registry library is Job Wizard. And then we support a lot of metrics, but you have to turn them on in the configuration. The metrics are divided into two categories, session level or node level. And here I give some examples on important session level metrics like bytes sent, bytes received. Those are about throughput and how many SQL requests in this session. And node level metrics, including something like pool open connections, pool available streams, the requests that are in flight. That means the driver sent out the request but does not receive a response yet. Those can give you some insights on how you can tune your performance. For example, if the available streams is very low, then you can add more connection to your pool. Yeah, next let's move on to performance tuning. So those parameters in the configuration, the default values are usually good enough for most of the applications, but if your application is designed to handle very heavy load, then you may want to tune these several parameters. Like you may want to increase native IO group, max requests per connection, and pool local size, pool remote size. Again, I cannot give you recommended values. You sort of need to test it out in your own environment. Apart from that, if you are reading very large texts, they may benefit from compression algorithms. So if that's the case for you, you are recommended to turn on compression. Now let's move on to programming practices. First, session management. Please only use one session instance for one cluster. You should just create one session instance and share the instance through the whole application. Here, this snippet, I give an example of using the Java try with resource syntax. And this try with resource syntax at the end of the block, it will implicitly close this session. So I hope you keep in mind that do not open and close session for each query, and especially keep in mind that there is an implicit session close if you are using try with resource syntax. Next, prepare statement. Just like a lot of other databases, you are recommended to prepare a statement if it's repetitive, so that you only need to prepare the statement once and then bind different values when you execute. Please do not bind unnecessary null values, because those null values will generate tombstones in the database, and which will have performance overhead, and it's unnecessary. Batch data retrieval. So let's say your application, you need to make multiple database queries, but those queries do not depend on each other. Then what you can do is just you send out all the queries at the same time and then wait for all of them to come back concurrently, instead of something like send out the first query and wait for the first one to come back and then send out the second query sequentially. Right? Doing it concurrently is basically faster. And you can achieve that by using the async API. Here is an example how you can do that. First, you create a list to hold all the features, and then in a for loop, you use session execute async. This will give you a feature, and then you add this feature to the list. And then you just wait till all the features in this list to finish, to wait for their responses. And then you can process the result however you like. Also, if you know you are going to execute several statements that are in the same partition, then you can use the unlocked batch statement. This is faster than the locked batch the locked batch statement type because the locked batch statement has performance overhead. Now paging. So if you know that you are going to select a lot of records, then you don't want to use the all methods because it will really just fetch all the records. And this can give you out of memory error. What you're recommended to do is to use an iterator. Basically reading the row line by line. And also it is by default paged. That means at first you only fetch the first page by default 5,000 records. If you want to change the number, you can change it in the configuration. And only when we want more, we want the following records, we send the request to the database to fetch for more pages. So reading the rows one by one or reading the pages one by one, in this way, the resources your application is using will be more controlled. Exception handling. Here are several common exceptions. The client-side common exception is driver timeout exception, and the server-side may return something like overloaded exception, read timeout, write timeout, and unavailable exception. You can determine how you want to deal with it. For example, overloaded exception and unavailable exception, that means the data mutation didn't happen because the statement is not executed in the database. Then maybe you can retry it. But if it's write timeout exception or driver timeout exception, then we don't know whether this statement is executed or not. We don't know whether the data has been changed or not. Then you can choose what you want to do based on your application logic. That's the end of it. I put together an application template because I know sometimes those configurations is not easy to get it right, especially the metrics. So I put together a project, a Maven project that you can check out. Here is the link, or you can also search Cassandra drivers, best practice, and examples, GitHub, and you will find the project. Thank you very much for my presentation, and I would love to hear any feedback or any questions from you.